Here we're asked to solve x squared y double prime plus 3xy prime plus y equals x to the 1/2. Now, to me, this is a second order linear equation, and it appears to be Cauchy-Euler in its basic form, but it's non-homogeneous. All right, so let's solve this. So let's find the y sub h. All right, let's find the y sub h. So let's solve x squared y double prime plus 3xy prime plus y is 0. I see this is a Cauchy-Euler form. So I assume y equals x to the r, and x is positive. And so then that gives me the auxiliary equation. Let's see, I would have a 1r squared plus a 3 minus 1r plus 1 equals 0. So r squared plus 2r plus 1 is 0. That's r plus 1 squared. And so then r equals -1, and it's a repeated root. So what that tells me is then my y sub h would be c1 x to the -1st power plus c2 x to the -1st power times the natural log of x. All right, so then what I take from this now is this x to the -1st and this x to the -1st natural log x. Those I will use later on as my y1 and my y2 for the non-homogeneous part. All right, so second, we have to find the yp. I cannot use undetermined coefficients. I do not have a constant coefficient equation, so undetermined coefficients will not work. I am going to use variation of parameters. So now I'll do that, but first, what we've seen is we have to rewrite the equation in an appropriate form, the differential equation in appropriate form. So let's rewrite the dE. And so to do that, remember we want the coefficient on the y double prime term to be 1. So rewriting the dE, I then have y double prime plus 3 over x y prime plus 1 over x squared y is equal to x to the 1/2 divided by x squared. That would be x to the -3/2. And so this x to the -3/2, that's what I will identify as my f of x in the system of equations for the variation of parameters technique. All right, so taking y1 as x to the -1st, well then y1 prime is -x to the -2nd. Taking y2 to be x to the -1st times the natural log of x, then y2 prime would be -x to the -2nd natural log x plus x to the -1st times, well, the derivative of natural log x is 1 over x, or again x to the -1st. And so then this is -x to the -2nd natural log x plus x to the -2nd. All right, if we assume that yp takes the form y1 times some u1 plus y2 times some u2, and we've derived the system of equations for this, then what we find is then x to the -1st, y1, x to the -1st times u1 prime plus y2, x to the negative first natural log x times u2 prime will equal 0. Okay, now the derivatives. Negative x to the negative second u1 prime plus negative x to the negative second natural log x plus x to the negative second u2 prime will equal the f of x, the x to the negative 3 halves. Now we have to solve this system of equations. All right, so let's do a little bit of arithmetic here. Let's see. So I need to solve this system, and I see right here on the first two terms, that's a fairly easy multiplication. Let me multiply the first equation by x to the negative first. Then that will give me an x to the negative second u1 prime plus an x to the negative second natural log x u2 prime is equal to 0. And let's add those equations together. Adding those equations together, the first terms add up to 0. Now notice I have a negative x to the negative second natural log x u2 prime and a plus x to the negative second natural log x u2 prime. Again, those add up to 0, leaving, after we add this all up, x to the negative second u2 prime is equal to x to the negative 3 halves. Multiplying through by x squared, u2 prime is equal to x to the 1/2 power, which then means that u2, finding an antiderivative, would be 2/3 x to the 3 halves. So I now know the u2. Alright, so now let's use this fact that u2 prime is x to the 1/2 power. I know then that x to the negative first u1 prime plus x to the negative first natural log x times u2 prime, make a substitution there. Here's the substitution, x to the 1/2 equals 0. So then if we solve this for u1 prime would equal negative x to the negative 1/2 natural log x over x to the negative first power. u1 prime is negative x to the 1/2 natural log x. So then u1 would then be the antiderivative, negative antiderivative of x to the 1/2 power natural log x dx. And here if you use integration by parts, I would use integration by parts with u equal to natural log x. So then du is x to the negative first, dv is x to the 1/2 dx, and so then v is 2/3 x to the 3 halves. And if you go through this integration by parts carefully, you find that u1 is then negative 2/3 x to the 3 halves natural log x plus 4/9 x to the 3 halves. So I now have the u1 and I earlier had the u2. Alright, so then that means, putting some stuff together, so then the y sub p, remember, was y1 u1 plus y2 u2. y1 was x to the negative first power. u1 was negative 2/3 x to the 3 halves natural log x plus 4/9 x to the 3 halves plus y2 u2 plus y2 y2 was x to the negative first power, natural log x, and u2 ended up being 2/3 x to the 3/2. So now there's the yp, but if we sort of look at this, we might notice that, hey, there's probably it looks like there's a like term here. If we simplify some stuff here, taking this x to the negative first power and distributing it through, I'd have negative 2/3 x to the 1/2 natural log x plus 4/9 x to the 1/2. And then reordering these terms and simplifying, or reordering the factors and simplifying, gives us 2/3 x to the 1/2 natural log x. And we hopefully notice that these terms add to 0, so then the yp is 4/9 x to the 1/2. So the general solution then is y equals y sub h plus y sub p. And so that would be c1 x to the negative first plus c2 x to the negative first natural log x plus 4/9 x to the 1/2 power.